Hello, and welcome to Introduction to Moving Objects or Moving Architecture in Unreal Engine 5 through the use of Blueprints for Beginners course. I will come up with a better name a little bit later once I actually upload this video. So the end result of the course, the aim of this, or this tutorial, I guess in particular, is going to be, I'll just show it right now on the screen. That's what we're going to be doing, and it's going to be a form of, this kinetic architecture. You have a central spinning core, you have secondary cores, and as they move, the interaction between different dynamic points drives, architecture, or drives the geometry. So I still have no idea how the final output is going to look like. Hopefully, me showing you that you already do. But yeah, I guess we can just kind of dive into it and begin. So the first step is actually not 3D modeling, but I think we first need to create the logic of how things will move. And for that, we need to create our first blueprint. So here in the bottom side of the screen, by the way, if you don't see this, click on the content drawer right here and click on Dock in Layout right here, and then you will have this content browser always opened, right? So in this content browser, under the folder named Contents, I will create an additional folder, and that's where my stuff is gonna live. So right click, choose New Folder, right click anywhere on the empty space, choose New Folder, and write down let's go My Stuff. Double click it to open it up, and inside I will just create a new folder, call it My Geometry, and one more folder, call it My Blueprints, or My Blueprint. Well, My Blueprints, it's gonna be multiple, maybe, we'll see. Okay. So with that done, inside of my blueprints folder, I will create the first blueprint. So right click and choose Blueprint Class right here, right? So once you open this up, it asks you what type of the blueprint is it. So we will choose Actor because that's the most versatile, I guess, or the most default version of it. It actually does not really matter that much. So we will use Actor Blueprint like that, and I'll call it My First Blueprint. Let's go for that. You can call it whatever you want, right? With this blueprint created, I will double click on it to open it up. Ta-da! New window pops in, and that is where all of the scripting can be done for our blueprint. So to dock it, because we kind of want to have it maximized, and you don't want to just maximize the window like that, because then you need to kind of switch between windows constantly, and that becomes a hassle. So instead of enlarging the window, we will drag the top tab of the blueprint. Just click and drag from the top tab onto our screen right here, right next to our map. There we go. So now it's docked here, and we can easily switch between our level and our blueprint. Okay, so what do we see here inside of the blueprint? On the left-hand side, right here, there are all of the components that the blueprint has. Currently, the blueprint only has a single component, and that is the scene root. This is where our the origin. You can think of the scene as a point. So this is where our origin of all of the geometry that is going to be built is, right? And you can change, once you have this selected, you can change well, never mind. You can't even change the position of the origin clearly, because it's always 0, 0, 0, right? My bad. Anyway, so that's our default scene root. Clearly, we will need more than that to make this thing work. Then on the bottom left, we have all of the different variables, macros, functions, and so on. So everything that is used as either a numeric value or a function, so a script, to drive the blueprint to create an action will be listed here. So currently there are 3 events. Event begin play, something that happens when you begin the play. Event actor begin overlap, something that happens when your character steps into the blueprint or into the zone of the blueprint. And event tick, something that happens on an internal clock of the game very, very often. We will be able to show you that a little bit later. Construction script, so what happens even before you press play, so how does the blueprint get constructed, and variables. Right now there's no variables present. Then here you have the viewport. So the viewport currently does not show anything because it's just an empty scene. You have the construction script, which again, this chain of events or chain of nodes would drive the geometry or creation of geometry or manipulation of geometry even before the game has started, right? So the good example would be, when you press the play button on any game and there is the period of time where it's loading. So some of that time is all of these construction scripts actually building out your level, right? So construction script does that. This is actually the closest to how Grasshopper works. It's a single chain of commands that is, actuated all at once. And then you have the event graph. This is something that happens dynamically. So event begin play, when you start the game, you can trigger something to happen. When event begin overlap, when your character steps onto the blueprint, something can happen, or event tick, something can happen very, very often on the internal clock of your game. In this case, I would argue that the cleanest way to do it, so that you don't get confused, is to just select everything and just delete. Yeah, select these 3 events and just hit delete so that they're not in the way. And we will be creating them from scratch a little bit later. In terms of construction script, you don't need to delete that because that's the only thing that it actually does. So it's not even a variable. Okay, now let's create a box and let's spin the box around a z-axis, just so that you understand how blueprints work. So first up, in the blueprint, we need a box. I will select my default scene root. This is going to be the parent of my box, and I'll click the add button. So click that. And after I've clicked the add button, I will choose cube, for the box. Click that, and ta-da, cube is created. Now carefully look at the offset, I guess, from the side of the screen, right? So I have the blueprint itself, and the blueprint has the default scene root, the 0, 0, 0 coordinate, and then a cube is attached to the default scene root, right? So it's a part of the not geometry, but it's basically the default scene root is the parent of the cube, right? And the cube is the child of default scene root. So if the root moves, the cube will move with it. If the cube moves, the root will not move with it, right? That's an important distinction. We will come back to that a little bit later. Okay, so now we have the cube here. I will go to the event graph because I want the spin to be visual, to be visible. Event graph. And I will create something that is quite simple, I think. Yeah. So as the game starts, the cube should spin. And it should spin 360 degrees. Okay. So First of all, we need an event that would trigger the spin of the cube. We already deleted that, so let's create it again. Right click anywhere on the empty space in the event graph and type in begin play. Event begin play. So this shoots out a trigger after your game starts. What should happen? Well, there's going to be a rotation involved, right? So let's type in rotate. And you can see that there's so many different, not ways, but different functions that have something to do with rotation. And honestly, I think if I were to scroll here, we would not even find the correct one, because the correct one is called set world, or set, yeah, for now set world rotation. And it asks me, should the world rotation be for the cube or the default scene root? It should be for the, in this case, for the cube. We're rotating the cube. With that being said, if you rotate the default scene root, the cube will also rotate because cube is attached to the default scene root. So you're basically would be rotating the cube's world, right? Cube's world coordinate, a 0, 0, 0 coordinate. Anyway, so now after event begin play, we need to connect it to set world rotation like that. So this triggers this, and then it needs to create a new rotation. And we can either type it in here, right? Because we want it to rotate, let's say 45 degrees or whatever, 135 degrees. You can type it in right like that. You can also type in make rotator like that. And then type it in here. You can also create a variable. But for now, let's just say around z-axis 135 degrees, right? So our very, very simple script here. I'll click on compile. Compile is a very important button because when you click compile, it bakes it into let's just say it like that. It makes sure that the script will run, and if it's not gonna run, it's going to complain during compilation process. Yeah, for a beginner, I think that's the best way to think about it. Always click compile. If you don't compile, it might not trigger an update, so to say, to your script. Hit save, and then go back to your map, and you can see that now even the preview of your first blueprint is a box, right? And let's just slap it in here, move it up, right? So that point right there is actually the origin point. You know, the center point of the box is actually the default scene root. And if I want to showcase the difference between these two, is I can just select the cube in the viewport, select the cube, and I can move it away from the root like that, right? So now the cube is here, but the default scene root is still here, right? So if I compile, save, and yeah, I don't even need to press play or anything, you can see that it's now off center, right? So that's important. And let's keep it off center, right? So if you haven't moved your box away from the default scene root, now have it moved. Back in our map, I will press the play button. And you can see there's no animation, right? It's just, but it is rotated. It's rotated 45 degrees. Let me hit escape, because originally it's aligned with the grid XY axis. And when I press play, it's actually rotated 45 degrees or 135, right? 90 plus 45. So it works, but there's no animation. How do you make it animated? How do you actually make it spin? Well, back in here, under my first blueprint, you go to the event graph, and instead of having a static number that just kind of snaps the object into place, you want this number to slowly increase. How do you do that? Well, use a timeline. So in between event begin play and set world rotation, we need a node that is called timeline. Let me drag out from here. Timeline, add timeline. Click that. You can call it whatever you want. I will just call it, yeah, I'll just keep it as timeline. Sure, why not? Like that. And then basically when you, it's like a graph, an animation graph. And when you begin the play, it's going to play that graph. We need to see it visually. Double click the timeline. This will open up a new tab, timeline, right? Where you can create a new track in the timeline. So let's make it like 10 seconds long, length 10, and just click on this plus track. Oh yeah, and choose that it's a float track because that's a single number. We want it to be a single number because degrees are single numbers. Add float track. And I can give it a name, and I'll just call it counter. Doesn't matter really. You can name it. My first timeline is also a good name, right? So now you have this curve here, this line here, that when you press play, or rather when the game begins, the timeline is going to kind of scan through this curve and will fetch any values that it can. So right now there's no value, so it's just going to always give you a 0, a nothing, right? So let me right click on the horizontal line here and add key. Add key. I'll add the key at time 0, and the value will be 0, right? So at the start of the animation, it will give me 0. At the end of the animation, I want it to give me 1. So I will right click again on the line, add key, but this time the time needs to be at the end of the animation, and we know that it's the length of it is 10, so the time needs to be 10 and the value needs to be 1. 10 at 10 seconds it's gonna be 1. And you can already see the slow increase, right? It's off, not off center, but it's like off screen. So you can use these two buttons to actually frame it properly, like that and that. You just click these two buttons and it frames your graph nicely. So 0, 0, 10, 0. Oh, sorry, 0, 0 and 10, 1, right? So that's our timeline done. If we go back to the event graph, you don't need to do this, but I will just kind of show you how it works. I will use what's called a print string. Print string just draws whatever text you want on top of your monitor. Yeah, on top of your view, I guess. So the counter output, I will plug that into the string input like that. So we begin play, timeline plays, string prints out the animation, or sorry, whatever the counter gives us. Compile, save, play. On the right hand side you can see it's slowly counting. It's going to be counting 10 seconds until it reaches 1, right? So that's the value slowly increasing to 1. Okay, cool. That means counter, let's stop. Always don't forget to stop your simulation like that. Okay, that means this number starts at 0 and counts until 45. Sorry, until 1. But we want it to count until 135. How do we do that? Well, we can, in this case, let's keep it simple. Let's just multiply it by 135. So counter, I'll drag out from it. I'll just type in, I'll type in multiply. Multiply. And here I'll type in 135. There we go. So 0 times 135 is 0. 1 times 135 is 135. And then so on, and everything in between, right? So like that. And I can actually also print it for you on the screen by just doing something like this. Easy peasy. By the way, to remove wires, you hold the Control key and you drag backwards. Okay. With this done, it's going to print out the actual angle of the cube, and it's gonna use that angle to actually rotate the cube. So let's see. Play. Awesome. Spinning. Congratulations. Now you have a spinning cube. Let me introduce you to a different concept. And that is, well, right now the cube is spinning around its center point, around its own origin point. What would happen if you don't spin the cube, but rather you spin the scene root? And remember, the root is here while the cube is here. I guess some of you will already know what happens when, you know, this is connected to this and this is spinning, right? Planets and moon and so on. So let's try that. So in the event graph, I will delete the cube node right here. And I'll drag in, so you just click and drag in the default scene root and connect that to the target for the rotation instead. Click compile, click save, click play. See? Now this is rotating around the center point. Around this point in particular. Let me do that again. It's basically where the character is standing. Right? Easy peasy lemon squeezy. If you want it to be more aggressive, let me do like 1080. So that's 3 revolutions in total. 1080. Oh, by the way, there's collisions as well. Well, it's a little bit too fast, I guess. Yep. There would have been collisions if it wasn't that fast. You can fix that. No, not the point of this particular tutorial. Okay, so we have this this rotating. Let's make something nicer with it, right? So let's first change the cube into a gear, and honestly, yeah, let's actually model out the gears first. So in my case, I already have them, right? It's very straightforward, and I used Rhino for this. You can use whatever software you want. It's very simple. I have these. 1 second. Nope. It's my bad. Duplicate border. Like that. These two are the same, so I'm gonna show it like that. So I have these two profiles that are very simple to draw. If there we go, that and that, and then center point, please. There we go. So if I have a line and I rotate the line with copy set to be true, and I believe it was 10, yes. Right, so all you need to do is just draw out this particular profile like that. Easy. And then array polar it around the center point by 36 times, right? Because it's 10 degrees of a gap. 36 times. and you have yourselves a gear. And oh yeah, and to have a twisted gear like this, right? You just make a copy of it upwards, like that, and rotate it by 10 or 20 degrees. I will go for 10, right? And then loft. Loft, make sure that the seam, well, it's trying to be smart with the seam. You don't want it to be smart with the seam. You want the seam to be an offset, right? Like that. Hit OK. Flip, cap. And after it stops crashing, it's going to give you, yeah, there we go, a gear, right? So that's the basic principle of this. In terms of the second gear, the smaller one that intersects here, if I were to draw, so the teeth are exactly the same, right? The teeth are exactly the same. And if I draw this and I rotate this 10 degrees, you can see that this is no good. And that's because this gear is 2 times smaller. The radius of it is 2 times smaller, meaning that it needs to be not 10 degrees, but 20. So you just do very basic math to, you know, understand the, oops, sorry, to understand the gear ratios, right? And you just work within that. I strongly suggest at the start to just use 1 to 3, 1 to 2, 1 to 4 reduction, right? So something very very easy to multiply or divide. So in this case, the gear is 2 times smaller, meaning it's 1 to 2 reduction in torque, I believe, or 1 to 2 increase in torque actually, and the increase in speed as well. So as this is spinning, this gear will spin 2 times faster, right? Okay, so that's the basic principle of these gears. They also have a shaft, a vertical shaft attached to them, like that. And on top of the shaft, I have these anchor points, right? So, with rods attached to the anchor points. So as these gears spin, these anchor points will spin with them, and these rods will always need to kind of fit between the 2 points, meaning that these rods will need to wobble. And we'll get to that once we get to that. For now, let's make 3 gears spin. Well, step 1, get the gears in Unreal Engine. To get the gears in Unreal Engine, you want to export the gears. To export the gears, you want to move or copy the gears from their origin points, and the origins are always the point around which the gears will rotate. Very important. Any geometry, the point around which it rotates needs to be its origin point. So you would select the gear and you would type in copy from the origin point to world 000. You can just type in 0 and it's going to copy it straight there, right? Like that. So what this initially does, it basically takes the gear and it just places it on world 000, and as it's going to be exported, that is going to be the point around which this whole geometry will rotate. A very important concept, I guess. Okay, let's export. Type in export, and then here I will just say for tutorial, like that, and I will just call it gear A. Gear A, and we choose Motion Builder FBX format. Hit save. Oh yeah, it's going to ask you to mesh the geometry. We're happy with either more polygons or less polygons, doesn't matter for this tutorial, so I'll just go for more, hit OK, and it just gets exported. If you get these settings, FBX export options, you don't need lights, you don't need views. For some reason my map Rhino Z to FBX Y is turned on. We will see if that is a problem or not. Hopefully it's not. Okay, let's import it. So back in our map, under my stuff, my geometry, I will just simply drag and drop the exported FBX. Give me a second. There we go. We have our gear A, and I just drag and drop it in. This opens up a new window for me where I tickmark build nanite and hit import all. Oh yeah, it's always gonna complain, that's fine, we just clear, close. That's interesting. So it kinda imports vertical. Okay, so you do need to tick mark that map Rhino Z to object Y. I thought that it wasn't necessary, but it is, because I'm using it. Past me is using it. I don't remember why, but clearly it's important. Right, probably has something to do with the left hand side coordinate system that or sorry, is it right hand side? No, it's left hand side coordinate system that Unreal Engine is using versus right hand side coordinate system that Rhino is using. Anyway, we have ourselves a gear. Let's go into our blueprint, and instead of a cube, let's make the gear. Let's add in the gear. Let's delete the cube, just like that. And instead, let's first create the origin point for our gear A. So back in here, I will check the coordinates of this origin point right here. So that's our gear A in the assembly, and I need to know where is it positioned, right? Where is the origin point? That's important. And I will just type in, I'll select that point and type in what, W-H-A-T, what, and I will get my X, Y, Z coordinates. And I'll just, well, I don't need to copy, or actually let's copy them, because they're pretty small and I want them to be bigger for you on the screen, right? We get the X, the Y, and the Z. Give me a second. There we go. Okay, so those coordinates will need to be transferred somehow into Unreal Engine right here. And for that, under the default scene root, I need to create a point. And the point is called a scene in Unreal Engine. So I will just select default scene root, click on add, and I'll add a point. Sorry, I will add a scene. I just told you that scene is a point in Unreal Engine. So I'll click that, right? I'll call it gear A center. Gear A center. And this point in particular will have the correct location, location XYZ coordinates. So I'll just simply copy and paste. Copy. Copy. And that's just 0. Okay, so now here it's correctly placed. And now under this point, I will add and I'll create a static mesh, right? I'll create a static mesh, and already since I have gear A selected here, it's going to use that as my static mesh. If it's not using that, then you can just simply, after you created it, click on here and find your gear A, or object A, element A, doesn't matter, right? Okay, still with me? You have your 0, 0, 0, you have your center point right here for gear A, and you have your gear A. Notice how gear center point and the actual gear are not on top of each other. That's bad. The reason is because Unreal Engine wants to help you by moving the gear back to 0, 0, 0 coordinate, right? So you can see that actually gear A has its own coordinates right here. We don't need that. So we click on this little arrow here for gear A, not gear A center, but the actual geometry. We click on this little arrow, and now it's centered around the point, right? So to make it work, if I go back to the event graph to make it rotate, then I don't need to rotate the default scene root. No. I only need to rotate the gear A center like that. And gear A will rotate with it. Compile, save, let's investigate. There's our little gear, and clearly it's off center, right? That's because of the origin. That's because in Rhino it's all away from the origin. I don't need this, I'll delete it. So it's all away from the origin in Unreal Engine as well. I press play, and yay, it's rotating. Sweet. Okay. So that's done. Let's make more gears for now. So we have gear A center, right? Let's select default scene root and click on the add button again, and click on add scene, and let's call it gear B center, right? Because it's gonna be the small gear. So back in Rhino, we need to get our gear B. So let me just quickly, it's gonna be a repetition of the same procedure. Back to 0. And I'll just export gear B. Okay, all exported. Back in here, under map, we just drag and drop in the gear B, like that. Same settings, basically just click on build nanite and click on import. Close, and we have ourselves gear B. So now back in my first blueprint, right here, in my first blueprint, under viewport, so that we actually see what we're doing, under gear B center, I'll click on add, make sure that it's selected. I'll click on add, and I'll choose static mesh. In this case, I don't have gear B selected, so it's just gonna say static mesh. I will rename it to gear B, and here I will just make it, or I will just choose it within my static mesh drop down list right here. Gear B. There we go. So now we have these two gears. Slight problem. My gear B center is still 0, 0, 0. We can't have that. And my gear B is also 0, 0, 0. We should have that because all of the movement is controlled through the center, right? So if I move the center, gear B moves with it, right? So back in Rhino, let's actually get the coordinates. That's our point. I'll type in what, and I'll get my point coordinates right here. minus 51,565. And minus 372,765. Bam. Something like that. Perfect fit. So with the camera speed set to smaller degree, this is something that we get. Let's double check here if it's, yeah, that's exactly what we see here. So that seems to be doing a-okay. Let's make these things spin, right? So event graph, set world rotation is now only being set for gear A. So let's create another one. Set world rotation, gear A center. I said the world rotation should be set for gear B center, like that. All right, and then we make another rotator, make rotator, and connect our degrees into that second rotator, just like that. So now both of them will spin. Compile, save, play. Ta-da! But notice how it's incorrect. And that's because there's two things that are wrong with this. The direction of the spin is incorrect. They need the small gear needs to spin in the opposite direction. And the speed, the second gear needs to spin 2 times faster. Right? As I said, because every T for this one is 10 degrees, every T for this one is 20 degrees, because the radius is 2 times smaller. So to mitigate that, all I need to do is just take whatever degree output I get here and multiply that by -2. Right? So it's 2 times faster and it goes in the opposite direction. Compile, save, play. Okay, that's way too fast. So let's do like 360 degrees for me to show you better. See? Clean spin. Okay, so we have these two gears doing their thing. Before we add the third one, let's create the rod in between them and see how that rod will wobble, right? That's quite important. So an important part of this tutorial. So for the rod, we actually need the 2 points above our above our centers, right? And in this case, I feel like we can. Nah, we should be accurate. Sorry, we should be accurate. I was starting to become a little bit obnoxious and just kind of creating points on my own free will. No. We will be accurate according to Rhino's coordinates. So gear A, top anchor point, what is going to be located at this coordinate. This coordinate is going to be created not, so you create this coordinate not connected to the center, but rather it's the coordinate from the default scene route. So make sure that you select default scene route, add scene, and call it gear A top point. Gear A top point, right? And then you use those coordinates. Did I copy them? Yes, I did. The Z is copied. Okay, so minus 103, minus 372, 436. Okay. So we have that. And you can see the point right there. This is not over for this point because this point needs to be influenced by the spin, by the rotation of this gear, right? So it can't just be connected to the default scene root. No, no, no. It needs to be connected to the gear A center. So you just drag and drop it onto gear A center, right? So now if you, if you rotate the center like that, the point here will rotate together with the center, right? This point right here. So that's important to first create the point in the default scene root and then drag it onto, you know, the appropriate center. Let me do the same thing for gear B. Default scene root, add scene, gear B center. Gear B center. Oh, I'm stupid. Not gear B center, gear B top point. Top point, there we go. Let's get some coordinates in there. These ones. Minus 74. Actually, let me just copy all of it in here. That's just gonna be easier for me. Like that. Yep. You only need to set it up once, by the way, so I guess that's good. Okay. And now we have a point right here, and don't forget to drag it on top of your gear B center. So we have the two pivot points. So as these two elements will rotate, these two pivot points or these 2 points will rotate with the elements, and then we can draw a rod between them, right? So let me, sorry, 1 second. We kind of want a rod, right? We want some sort of a stick to properly draw this. So let me model out a quick stick. Let me just get the length of this. It's 225 centimeters, let's say. And let me just create a cylinder starting from 0. Let's say 5 centimeters in diameter and 225, right? 225 centimeters. The stick, this, should not be vertical. It should be laying along the x-axis. That should be along the length of the stick. I will explain why in just a second, but it should be aligned with the x-axis. So I'll rotate. Like that. So that's our stick, and it's lying along the x-axis and starts from 0, 0, 0. I'll export it, and I'll just call it stick. And it's gonna be my FBX. There we go. Back in Unreal. Let's import the stick. Yep. There we go. We have ourselves a stick. In my blueprint, under viewport, I will, on the default scene root, I will create the stick. I will drag the stick, right? And it's going to be a part of the default scene root. So I'll click on add, static mesh. I'll call it stick. My static mesh is going to be the stick. Okay, it should be, yeah, it's right there. Okay, it doesn't look pretty at the start of the level because it's literally just kind of lying there on the floor. I want it to be moved to here. And I don't want to do it manually because it would be too much of a hassle to find the anchor. So instead I'm going to use a construction script for that. Not the event graph, but a construction script at first, right? So in the construction script, I will get my stick in here, drag and drop, and I'll say that actually I want to create a set world transform. Not a message, just set world transform. So I want to transform it. Transform means move, rotate, scale, right? It's going to be a new transform, so I will make transform like that. And it's going to have location, rotation, scale. Scale, we don't mess with the scale. We don't need to mess with the scale. Instead, we only mess with the location and rotation. Let's first do the location. Where should this stick be located? Well, if we look at the Rhino file, the location for this stick, it needs to start from this point right here, which is connected to gear A. Gear A top point. Okay, back in here. Under construction. Construction script, I have my gear A top point right here, so I just drag it in. Unfortunately, I can't just kind of connect it like that. That doesn't work, so I need to get world location. So I get the location of this point and I plug it into the new transform of the stick. If I now look at the viewport, if I compile and then look at the viewport, it's actually going to always follow the position of gear A top point. Very useful. Okay, now what? Now I need the rotation of it to always force the stick through point 2 or gear B top point. So it needs to be rotated downwards in this case. Under construction, again, we need to deal with rotation. And somehow we need to also, extract that kind of a direction between A point and B point. So gear B top point also needs to be here. And get world location also needs to be here. Right? So we know the location of point A and point B. What now? How do we get the rotation? Glad you asked. There is a command. And the command is called find look at rotation. Find look at rotation. Like that. Basically, it asks for the starting point and for the target at which it should look at. Just like that. And it gives you the necessary rotation. The trick is that this only works if your geometry is aligned with the x-axis, because it assumes that the x vector is the forward-looking vector of your geometry. This is the reason why we have laid our stick along the x-axis. Very important. Now I connect that to the rotation, like that. And still under construction. Compile. Viewport. Ta-da! Now doesn't matter where I move my point, the stick is going to move with it. Very useful, very nice. Okay, so with this done, it's not going to animate or anything like that. So if I press play, you can see that the stick kind of stays in the same place because event graph does not have anything that would deal with the stick, right? the stick situation. So we need to, we need to fix that. And to fix that, we will create a world transform in the event graph as well. And it's going to be literally the same world transform as what we had here. So that's a good chance for us to actually repeat the same script. Event graph set world transform for the stick, make transform, get gear A top point, get gear B top point, get location, get world location, sorry. That's the location of the stick from gear A top point. Get world location for gear B. Get look at rotation. Find look at rotation, sorry. Not get, but rather find look at rotation. Like that, and that connects to the rotation. Easy. Okay, compile, save, play. It's too high. Make it lower. Play. Nice. Okay, we have successfully created a stick that actually follows the geometry of, like, it's always going to work in a way that it's anchored here and it goes through this point right here, right? Okay, let's at the end of the stick we can create a box, right? So if I were to, for this stick, I can add, let's say, a box just like that. So cube is connected to the stick and I can move it to here and I can make it a little bit more flat. Remember, since stick is driving the orientation of the cube, the alignment, the X alignment is already clean, already there. So we can kind of squish it like that and then make it wider like that and just use that as a kind of a wall, honestly. Compile, save, press play, and now you have a stick that wobbles with the wall, right? Okay. So now next, and of course you can make copies of it and then so on, right? So you can make it as fancy as you want. You can also, I would just suggest, just keep modeling the stick here, right? You can make the stick fancy. Let's make the third gear. So at this point, repetition is going to be important. So I'm just going to kind of keep repeating things. So for default scene root, I will add a scene, call it gear C center, gear C center. For now, I will not do anything with the gear C center. I will not add any coordinates because I first will just create a static mesh in it, and I'll just call the static mesh gear C. And also for the gear C center, I'll add another scene and call it, no, sorry, you don't do that. We'll create the top point a little bit later. So for now, I have gear C, And the static mesh for it is actually going to be, I mean, we're just reusing the same gear here, so it's going to be the same gear B. There we go. Should be, yeah, there it is. So that's our gear C that still uses the same geometry as gear B because they're identical, right? And now let's create a center. Bam, bam, bam. There we go. Copy that coordinate. There we go. And for the center, up like that. Y minus 485. Okay, something like that. So now you will see it's a little bit of a mess. And the reason why it's a little bit of a mess is because here our gear is actually rotated, as you can see. It's looking towards the, it's looking towards the mesh, sorry, the center of gear A, right? So what we want to do is we want to fix it. We want to rotate it back, right? And I wonder if I wonder how we should do that. Like, there's two ways of how we can do that. Way number one, which is probably the easiest one, is just to introduce a little bit of a rotation for gear A. We can also add stuff. 1 second. Okay, I figured out the fastest way to do this. So we're going to go in here, and then simply for gear C center, I'm just going to introduce a little bit of rotation for it, right here, for the rotation, 10 degrees, because 10 degrees makes it snap into place, right? Like that. And then under, we can go for construction script. No, we go for event graph. When gear A rotates, gear B rotates, and then when gear C rotates, so we need to make a little bit of a gap here. When that is going to rotate, set world rotation, set world rotation for gear C, right? It should use the same, it should use the same rotation as gear B because they're identical, but it should have a 10-degree offset, I guess 10 degrees more. And we have already added 10 degrees in here to make it fit. So what I'm going to do is I'm going to say, okay, so for this get world or get relative transform or get relative rotation, that's enough for us. Get relative rotation and add it to the original rotation that is used for the gears, right? So you always will be adding those 10 degrees. So plus, I think, wait, no, that won't work. Oh no, that won't work because it's going to kind of keep on adding. So gear C will keep spinning faster and faster. Actually, we need to make it static object, which is fine. So sorry about that. So instead, for the rotation, let's make a rotator again. Make rotator. And then we will be using the same multiplied by -2 value, but in this case, we will also add 10 degrees to it, plus 10, just like that. And those 10 degrees will need to be, you know, the same amount of degrees that's added to gear C right here to make it fit. Okay, that should work. That should fix it. Let's take a look. Press play. Yep, everything fits. No collisions whatsoever. Okay, great. Now for the sticks, in terms of the sticks, we kind of do the same thing, right? So let's first create another stick, and this one will need to be longer, I guess, like that. Okay, it's not just gonna be longer, but it's going to go beyond the anchor point right here. So yeah, I guess it makes sense for me to showcase this to you. So we do distance, and I will just measure, okay, let's say 300 centimeters from here and 175 from here. Okay, so we start from 0, and I'll just drag out 300 along the x-axis, minus 175 along the negative x-axis. So I have two curves here. I'll just join them up into one curve, make a pipe. Start radius. What did I use? Like 5, right? 5 is a lot. Well, it doesn't matter. So we use 5 for this, and maybe I'll make something a little bit fancier here. Let's do a sphere around 0, and just make a little bit of a sphere here. Crack pipe. Let's go. Boolean union. Export. Stick 2. Save that. Yep. And then in Unreal Engine, we just import it in our map. There we go. So we have our stick 2. Here I will just select the fault scene root, add static mesh, call it stick 2, make everything else smaller. There we go. And make sure that it's actually set. The static mesh is actually set, right? So stick 2. There we go. Then, as per usual, it's right on our 0, 0, 0 right here. We want it to be from here to here. Did we forget to add the... Oh yeah, we did. We forgot to add the point above gear C, right? So I need to, under default scene root, I need to add a new scene, call it gear C top point. Back in Rhino, this point. What? Copy, paste. Wait, I'm drunk? Wait, didn't we already use this? Wait, or did I already copy this? I think I am... no way that I copied it. Okay, gear C top point, and let's just add in those coordinates, and then we'll know for sure if I copied it already or not. Like that, like that. Like that. Okay. Oops. Okay, so it's here. The reason why it's not fitting properly is because this rotation right here for gear C center, should not be 10 degrees, but rather should be 90. What I meant is minus 90, I think. And then let's check. Yep, now it's straight up. The reason is this and this. That's a 90-degree rotation, you know, from this to this, right? So just 10 degrees didn't work. So it needs to be 90. With that done, we need to actually rotate in our event graph. Remember where we're adding the degrees? So it needs to be minus 90, like that. Okay, let's go back to our script, and for gear C top point, we need to drag it to our gear C center, right? Because it needs to rotate around the center of this. Right, with that done, we go to construction script and we build a new set world transform for stick 2. It's literally going to be exactly the same script, so I'm gonna be lazy and I'll just copy paste. Control C, Control V, all of this. Don't forget to connect this wire so that this triggers as well. And I'll just switch this. Stick is switched with stick 2. Then it needs to start from gear A top point, right? Oh, not even that. The top point of gear A needs to be a separate point. See? There's a lower one and a higher one. For now, it's gonna be the same point. I'm lazy, so we're gonna do that. But then I will separate them. So it starts from gear A top point, but it goes to gear C top point, like that. Should be fine. Compile, viewport. Yep, that works. Starts here, goes to here, works as expected. And then in the event graph, we kind of need to do exactly the same thing here as well. So I'll just copy paste. Again, Control C, Control V. Instead of stick, we use stick 2. Instead of, no, we do use gear A top point, but here gear C top point. Plop. Compile, save, play. Is it? It's hard to tell. Okay, let's look at it this way. Play. I have no idea if it's working or not. So let's investigate. Gear C top point to actually, yeah, that seems like it's gonna work. And this actually goes through it. Let's create a sphere for it so that we visualize it, right? So I'll just create a sphere for gear C top point right here, zero it out, make it smaller, compile, save. Yeah, it's right there. Press play. Why is it not rotating? It's not rotating. Needs to rotate around the center, but it's not. What if I rotate it here? It works here. Why don't you work? Gear A top point, gear C top point, stick 2. Oh no, something's off, something's wrong. All right, I guess give me a second. I need to figure this out. I found it. I figured it out. So it was gear A center is being rotated, thus everything rotates. Gear B center is being rotated, so everything rotates. And here we're just rotating gear C, not its center. That's why. So we take gear C center and we rotate it. Thus the top point also rotates, and it's not just the mesh. See how easy it is to mess up? Now it works just as expected. Oh yeah, and I removed a few things to see better. So cube needs an actual cube. Stick needs an actual stick. There we go. Gear C top point does not need a sphere anymore. Okay. Now we're back on track. Press play. What? Oh, right. It's sunken down. There we go. That's bigger now. Okay. So that's how it works. Now, yeah, it does work. It does work. Meaning you can start connecting things to it and so on, and start looking at like different methods of interaction. My back is hurting me. Okay, let's add a few more things and then we will call it a day. So for now, this is the script. I think that works. Now, instead of event begin play, I do want to have the possibility to just press a button, any button on my keyboard, not any, but press the button to trigger the animation to play. So it does not play at the start, but rather I trigger it. So I'll go to third person map. I'll go to third person folder, input, actions. I'll create a new action because right now there's 3 actions: jump, look, and move. I'll create 4th one, which is going to be open, or 4th and 5th one, open and close. So right click. I believe it's gonna be under input action. There we go. Input action IA underscore open. And then another one, input action IA underscore close. Okay. So we'll have these two. You don't need to open them, no need to edit them. They're just actions that happen to be there. Okay. Now, one folder up, we have, third person inputs folder. This is where input mapping context is located. This is basically where you specify what button each action is triggered by. Double click that, expand mappings, and here you can see you have jump, move, and look. We need 2 more, right? So we click this little plus sign, and here we will choose open, input action open, and 1 more plus sign, input action close. Then we'll expand open and expand close. Click on this little keyboard icon, and then for open, I will press the F key. So it registers as the F key, right? For opening. And for close, I click this little keyboard icon and I press the G key, G to close, F, G. We save. Okay, and now we have the 2 inputs, to open and to close. Back in here for my first blueprint, instead of event begin play, we delete that. we will right click and we choose open. And here, input action open, enhanced action events, not values, events, IA open. I select that. And when this is, when it's triggered probably, yeah, let's play. Okay, compile, save, play. F, does not work. The reason why it's not working is because in Unreal Engine 5, I believe, starting with 5, every blueprint requires you to specifically say that that blueprint can read the inputs from your keyboard. It's an optimization thing. So at event begin play, we will enable input. And the target is going to be self, so the actor is going to enable input onto itself. But what's the controller? Well, we will get player controller. It's a single player, so it's very easy to get, right? Player index 0, the only player that we have. So this little thing enables you to input, to trigger things with your keyboard from the mappings menu, right? So compile, save, press play, F, ta-da, easy peasy. Now let's also be able to close it. So enhanced, or rather we can just do IA underscore close. Enhanced action, close. And to close something, we just play the same thing in reverse. Just like that. Compile, save, play. F, G, F, G. I'm bad at this, apparently. Okay. I hope that I won't slide down. Anyway, so that works. And you can reverse the animation now. Sweet. Now we have, now we're cooking. Now we're starting to actually cook, all right? We have full control over the animation. We have our timeline that can also be smoothed. By the way, for the timeline, you can change how linear the animation is by right-clicking on the nodes and choosing auto instead of linear or constant. In this case, I will not be doing that. Then here we don't do anything. Let's attach some things to stick to, I think. Add cube, move it, movement right here, scale it, oh, not like that, squish, squish, squish. Maybe it can be rotated around X a little bit. Something like that, and then scaled around Z. Something like that. Let's see how that would work. Play. F. So you check if they are intersecting or not. That was close. It's not intersecting. Okay, and then we can do one more cube, and that's gonna be the end of it. Promise. Let's just move some things around. Like that. For stick 2, I'll add another cube. Move it in here. Flatten it. Scale it along both X and Y to make it wider, and maybe one more. Promise that's gonna be the end of it. And for cube 2, I'll just copy and paste it so that I can do something like this, and maybe add a little bit of Y rotation like that. You know, so we're starting to build up some form of architecture. It's not going to be pretty, for sure, but it's going to be something. Also, it's intersecting like crazy. It is what it is, right? But it works. Okay, I think we end it here. I will now do like a quick time lapse of me just cleaning this up so that you see the same thing as what you saw at the start. It's not going to be any new functionality. I'm just going to move some boxes around that are connected to these endpoints, and I will kind of keep triggering them until they work nice. But yeah, there's going to be 2 more tutorials. One is going to be in relation to this, me just kind of continuing to work on this to make it a little bit better, and introduce a few more functionalities so that you are a little bit more of a intermediate user rather than a beginner user after it. And the second one is going to be creating something that is a little bit more interactive, in the sense of you don't need to press any buttons. The structure actually interacts to you as you walk, let's say, right? So those are going to be 2 additional course tutorials. Anyway, let's do a time lapse, and then I will not say bye afterwards, so I'm saying bye now. Bye. you.